Thank you and welcome everybody to my talk about how you can compromise ADFS certificates, and a couple of ways actually. So short about me, so I'm Nestori from Finland. Hi. I'm a doctor, but not retired as the keynote speaker is, so still practicing my doctorism with Azure AD. And I think most of you know me best of my tool called AAD Internals. And I work in a company called SecureWorks with Ryan, who's in the first row. And I work there as a security principal security researcher. So they actually pay me money to study this. Can you imagine? Like it so much. And a couple of my major achievements from the last year. So last year in Black Hat USA, MSRC is published a list of the most valuable researchers. It's here. And I'm on the list. So I finally made it. And one of my colleagues said that, well, at least you were the best Finn. Guess what?
You can now retire.
I wasn't. So there's always someone better from Finland than I am. And the second one, I think that this might be even my best achievement ever. So you guys know the MSRC. They are following only 75 people, and I'm one of them. About my toolkit AAD Internals, just a couple of words. So I'm using that to do some live demos. So let's play the demo cards. So that's an admin and hacking toolkit for hacking Azure AD and Office 365. Of course, you can do some blue team stuff too, like download some logs that you can otherwise do, but mainly it's for hacking. It's an open source, and it's also listed in MITRE attack tools, and according to them, it's actually used by APT 29, also known as Nobelium and other fancy names. But then for today's talk, so I'm going to cover these things. So first, a short introduction, what is Identity Federation, what is ADFS, what is Golden SAML, why we are talking about that. And then I'm going to show you the attack path, or graph, if you will. So there are different ways to get to your objective. That is, that you are able to create Golden SAML tickets. And finally, I'm going to tell you a couple of hints how you can protect against these Golden SAML attacks. And let's start with concepts. So we have the service provider. In Identity Federation, I mean, there are a couple of things, and the first one is service provider. And you as a user, you want to consume services, right? So you need some identity provider which can identify you, and in this case, it's your on-prem ADFS server. And you want to use the service, but the service provider doesn't trust you, and that's why we need this identity provider. So the identity provider, the service provider, which in this case is Azure AD, is trusting your ADFS, on-prem ADFS server, and ADFS server is trusting you because you know your password. So that's like ADFS server is trusting you. But how can you now access a service so that the service provider is trusting you? Well, that's where the security token comes in place. And that's called SAML token. And that SAML token is signed by the identity provider and therefore trusted by the service provider. So as long as you as a user can provide that SAML token, you can consume the services. So that's basically the whole idea here. And if we look under the hood a little bit, we can see that there are two authentication flows. The first one is so-called normal one. So you say, let's say you go to your Office 365 email. So you first access the service provider, and service provider notices, okay, you are not logged in. Go and log in to your identity provider. Then you go there, you get the SAML token, and then you go back. So that's kind of normal authentication flow. But Azure AD also supports so-called identity provider initiated flow, which means that you can just go to your on-prem ADFS server and say that I want to access this server, and it will create a SAML token for you. And with that, you can go to service provider. And the first one The service provider initiated is meant for situations that you, as a service provider, want to control the flow so that there are some context sent back to identity provider, and then with the same context you go to there. So it's pretty much kind of what Dirk Young said about having the nonce. So it's pretty much the same thing. But Azure AD doesn't care about that. So actually you can just go, if you have a SAML token, you can go directly to Azure AD. And that's the golden SAML attacks, actually. So golden SAML attack is abusing that identity provider initiated flow. So instead of going to identity provider, you have stole the certificate that the identity provider is using to sign those SAML tokens. And you are signing them by yourself and just going to Azure AD. Hey, I'm Nestori. And Azure AD says, yes, welcome. I trust you. You have signed the SAML token. So to be able to do this attack, you need to know three things. Well, you need to have one thing, and you need to know two things. So you need to have the token signing certificate with the private key. So that's the first requirement. Second one is that you need to know the issuer URI of that federated domain in Azure AD. So it's kind of ID of that identity provider. And third one, you need to know the immutable ID of that user, which, as we remember from the previous talk, is normally the GUID of that user's on-prem AD object. But it can be anything, but that's what it usually is. And in this talk, we are focusing on the first one. So how you can get those signing certificates and the private key. And let's talk about the history of golden SAML attacks. So everything started, at least as far as I know, in November 16 on 2018, when I wrote a blog about making a backdoor to Azure AD. If you are a domain admin, you could register a federated domain and said that use this certificate. And I was able to prove that you could actually log in as any user you want to by just providing the correct immutable ID. And 5 days after that, CyberArk published their blog, and they actually coined the term golden SAML. So that was the start for that. And by the way, at that time, nobody knew me, so nobody read my blog. And I even published the first version of AAD internals only in 2018. And that also included all the things you need to build those graphed ADFS tokens. I just didn't know how to use the certificates of existing ADFS servers. So I tried to study that a lot, but couldn't manage. But then came TROOPERS22. And a couple of guys from FireEye, or Mandiant, I think that was called FireEye at that time, they were able to do that actually. So they published two tools, ADFS dump and ADFS spoof. And a couple of months after that, I was able to implement that also as a part of AAD internals. And at some point, I think it was close to the end of 2020, something happened. Solargate, anyone heard about that? So everybody suddenly was interested about this. So before that, actually, before I published my first blog, Microsoft said that this is not a security issue. I still have that in my blog, if you go and see. But now they are considering this to be a kind of a problem. Okay, and then in April last year, actually me and one of the FireEye guys were coincidentally researching whether we can do this remotely. And we were able to do that, and we will get back to that later. And a couple of months after that, a couple of my colleagues, they were able to build a tool chain to do this whole stuff remotely, just by providing a couple of credentials, and you could do this remotely without need to compromise ADFS servers anymore. And then there are a lot of links which you can click when you get the slides after the conference. Okay, so what is ADFS? So for short, it's just a Microsoft identity provider that comes as a part of the Windows operating system, and with that you can kind of federate the identity outside of your on-prem environment, like to Azure AD or any other service. And it has a quite powerful claims rule language. I think most of you know what is a conditional access in Azure AD, right? So this is basically the same, but you can do very fine-grained rules, whether allow the user login or not. Like, for instance, if your shoe size is more than 26, you are not allowed to log in on Fridays after 5. So you can build that kind of rules. And it supports all the industry standards like SAML, SAML2, OAuth, and also it supports multiple authentication methods. So form-based authentication, I think you all have used that. Windows integrated authentication, certificate authentication. You can have your own MFA providers, and so on and so on. So there's a kind of lot of things that supports. And then before we go to the good stuff, very short, high-level introducing to ADFS architecture. So here in the bottom, we have ADFS servers, so 2 to many, because that's a requirement that you should have at least 2, because if one is down, that would be a single point of failure and you can log in. And then we have a load balancer, because all of these servers are answering the same URL, so that load balancer must divide the traffic using some algorithm, whatever you decide to. And because you might want your mobile workers to be able to log in, you can't do that from your internet or your local area network. You need to have proxies. And again, because these servers are domain joined, you don't want to expose them directly to the internet, right? So you need to have proxies. And they are on the DMZ. And you also need to have a load balancer there. And your domain joined and the people who are logged into your domain, they can consume the ADFS servers, and the people outside, like most of us are now, they need to use those proxies. So this is like a basic configuration, just for background information. And then when you are configuring ADFS, you have a couple of options and decisions you need to make. And the first one is which kind of certificates you are going to use. So are you using the managed one, which is the default one? And if you are using managed, and by managed I mean that ADFS is taking care of renewing them once a year, so that's the default. And if you are using that, it's better for attackers because those certificates are stored in configuration database, right? And they are encrypted using a DKIM key, which is stored in Azure AD. Sorry, on-prem AD, not Azure AD. And another option is to use custom certificates, which means that you need to create those by yourself. So you might have a CA in your AD environment already, so you can use that to create those, but you need to remember renew them, depending on how long you want them to be valid, so it's up to you. So this is the first decision you need to do. And those certificates are stored in a certificate store on each ADFS server. So you need to also distribute them to all servers if you are doing it by yourself. This is a little bit more safe, I would say, but it has a management burden. But it's up to you. Well, we'll see after the show which one you would like to have. Okay, the second decision is that where do you want to store your configuration? So the default one is that configuration is stored in Windows internal databases, also known as SQL Express. And that configuration is on each ADFS server. Or you can use the SQL server, where all ADFS nodes are connecting to. So these two options you have. And they are kind of also the reason for certain, let's say, branches on this ADFS attack graph. So now we are getting into the fancy stuff, why you are here, okay? So the first kind of a decision point is that which kind of certificate you are using. So are you using the custom one? And we start with the custom. And the first question here is that, is the private key exportable? And if it is, you can export that using MMC. So nothing like a fancy there. But what if it's not? Then you need to export that using some tool. So if you want to use MMC, as I told you, the certificate needs to be marked as exportable. And if not, you need to use tools like AD internals or Mimikatz. Want to see a demo? OK. Let's see how my demos are working. And whether I can see it, because I need to look there. OK. So first I'm going to open up the ADFS management console. Let's zoom a bit. And we can see that here are the token signing certificate. And as we can see, it's not self-signed, which means that it's not a managed one. So ADFS server is not renewing those. So we need to do it by ourselves. Okay. And when I go to MMC, let's zoom a bit. So this is the correct certificate. I go here and right-click. Right-click, OK. All tasks, export. I hit next. And we can see that, it's grayed out. So we are not able to export that by using MMC. So what we need? Tools. And it happens that I already have a tool here. And actually, this new version I created just for this occasion. So it's called TROOPERS22. And it will be published later this week. There's some things I need to fix, so they are not working properly. But anyways, here we are, logged in the computer that has ADFS, and it's using those custom certificates. So all we need to do is to say export AD-int ADFS certificates, hit enter, and we should have them here. And we have. So 2 PFX files, no password, ready to use. Good. OK, so let's move forward. And the second kind of thing here is that if you are using managed one, then there's 2 paths, parallel paths. And the reason for that is that if those certificates are managed, there's 2 things you need. The first one is the key, and the second one is the configuration, because you need that key to be able to decrypt those certificates which are inside the configuration. And there are different ways to get both of those. And we start with the key. Well, usually we do it another way around, but this time I decided to do it this way. So first the key, and then the access. So do we have access to that ADFS computer, or do we need to do that remotely? And the first one is that remote, and we have a couple of methods. And the first one is LDAP, which means that I just need to make an LDAP query to find the correct object and then extract the key from that AD object. And to find that, that's actually quite tricky. So here it is. So first of all, usually we need to have the configuration first, but for this demo, I do it the wrong way around. So in that configuration, it says that what is the group where the key is. And the key group is actually an organization unit under your AD, and there's a program data, Microsoft ADFS, and then the organizational unit, or I think that's called organizational unit, yeah, where the key is. And inside that container, if you will, there's a contact object that has a name crypto policy. And inside that, there's an attribute called display name, and there's a GUID. And then in that container is another contact object that has an attribute L as a location, and that location matches the display name here. And then inside that object, there's a thumbnail photo that is the actual key. Right? So not so easy to find. But because now we know that, it's actually quite easy. So you just do a couple of queries, and that's it. So I'm not going to walk you through this all, but here you get the group from the configuration, then you derive all the other things, and then you find the first one and the second one, and finally you have the thumbnail photo, and that's the key and key you need to use. Okay, so that was the first one. I don't have demo for this because this is like an old school now. But the second one isn't, and that's the DC sync. So that's the other way to do this, like remotely. So if you don't have access to, I think I said ADFS, but I meant like your domain controller. So you can do it remotely by using DC sync. And DC sync is the same protocol that domain controllers are using to replicate data. And I actually implemented this to AAD internals by borrowing code from DS internals. So there's a custom DLL that helps to do this. And to do that, you need to have an account that has permissions to replicate users or replicate directory changes. And those are usually not that easy to get. And the possible targets are domain admin. Well, of course, if domain admin account is compromised, you own the domain, right? But if you are using ADFS, you also are using Azure AD Connect, because the user objects are synchronized with Azure AD Connect, but the identity, like authentication, is provided by ADFS. So that's a good place to get those kind of credentials. And I'm going to show you a demo about that. So I'm going to go to AAD Connect server, and I have a session here, a PowerShell session. I'm logged in as a local admin, so you don't need to be like any domain admin or anything, just local admin. And I'm going to import the module here. Okay. Why is it saying that? Stop. Okay. Or did I already import that? Guess not. So I'm going to save these to variable, and there's a reason for that. So one command and voila, you have the credentials. If you don't believe me, I can show them to you. Well, partly, not all, because I don't want you to see my password to cloud. We won't tell anyone. Yeah. I hear that a lot. Okay. So this is actually the credentials of the service account is using to access your on-prem AD. And we have a nice username and a machine-generated very long password. That's what Hey said that we should have. And that's a nice one. But now when I'm running this command, Azure AD, the AAD internals is elevating the current user first to LSAS, and after that to Azure AD Connect. And therefore, this session is broken. I can't do anything here. Like if I want to say, who am I? It should say, you can't do that. Well, you can, but access is denied. So I need to do a trick here. I'm going to say, convert to JSON, and then set clipboard. Okay. So now we have the credential object on clipboard. Now we're going to change to, I think it was this server. Yes. No, it was the other one. I think so. Okay. No. Sorry about that. My bad. So I need to remain on the same server, actually. Okay. And I have another session here already loaded the module. So I'm just going to copy those credentials from clipboard, and then I'm going to create a credential object here. Hope that worked. Oh, went too fast actually. So I did already everything I wanted to. But to get the, just clear that. Okay, so I go now back here, And I'm just going to pick any of these, so it doesn't matter for the purpose of demo. So I'm going to pick this one, and where's the name? Is that the name? Common name. And let's try to search user with that one, like this. And that's the object ID of that. And now when I copy this one, and add it to another command that is using the DRS or DC sync actually to perform this, it needs an object GUID as a parameter, and then the server where it wants to connect, and then the credentials, which we just stole from the AD connect. And now that's the hash, empty hash of that user. And what's the difference between this and the LDAP version is that the LDAP is more noisy. This isn't. So this is just a quick one call, and it's quite easy to blend in with the like legit requests. So that's very easy. Okay, so let's move forward. So next will be that if you have a local access to ADFS server, you can use .NET reflection to get the key. And what the heck does this mean? .NET reflection. So let's talk about that. Have you heard about Nobelium Foggy Web? Yes, so they use that actually. And I've been working with a guy from Mystic or Microsoft, whatever, can't remember where those letters come from. There's a guy called Roberto Rodriguez, and we have worked together to implement this also to A80 internals. And let's see how it works. So there's a code from A80 internals. I'm not even thinking that you can see that, but that's okay. I'm just walking through quite quickly. So how it works is that we load a couple of DLLs, and then we're going to get a utility that allows you to convert your XML configuration to an object. And then we do that. And then we continue, and we are going to load that configuration to one of those, let's say, classes we loaded. And that kind of populates the service settings field, if you will. And we are going to get that instance here. And then we are going to get a certificate protector from that object. And from there, we're going to get the DKM instance. And then we are going to say, enumerate the keys. And there's only one key, as far as I know, and that's the correct key. And if you are doing this in ADFS server computer, that's almost impossible to detect, because everything seems to be legit. ADFS account is accessing on the backend AD and getting that, and there's nothing like a phone in there. So that's kind of a most stealthiest way to do that. And now it's implemented in A8 internals, which I'll be releasing shortly. So that means that all the detection stuff you have built doesn't work anymore. Well, they work if I would use those methods, but this new method kind of quite easily bypasses those. Okay, so those were the ways how you can get the key. Okay, and then we move forward to getting the configuration. And, oh, sorry, wrong way around. So here we are. So the first decision here is, do we have access to that ADFS server? And if you do, you can access the configuration database just by, making SQL queries. So it means that you just read the configuration, and you can get the configuration string for that database. And it doesn't matter whether it's the SQL server or the Windows Internet database. That doesn't matter. So you can get the connection string by using WMI query or Windows Management Interface query from the ADFS server object, or you can access the configuration file, and it's there. And when you have that, you can just simply connect to that DB. And again, I don't have a demo for that because that's old school again. I have a better way to do that. But here it is. So you connect to SQL database, you are getting the service settings data from a certain table, and that's it. You have the configuration. And the better way to do that, if you have local access, is again the .NET reflection. And this is based on that the service properties object is having a private property called service settings data. So which means that there's a command that admins can use. I'm going to zoom that a little bit. There it is. Oh, that's better. So this one here. So this is a legit command that admin can run to see what is the ADFS settings. But that includes the private property, which you can access using the .NET reflection, and that allows you to get the configuration without need to connect to any databases or anything like that. And this is also quite hard to detect. And that was brought to you by Microsoft. So it has been there since 2018 in ADFS Toolbox. So there's a link in GitHub, which you can actually see. So it has been there like ages. But I think Foggy Web was the first to find that and to use that, and now we all know that. And in AAD internals, we do the same. So we get the ADFS properties, and then we get the config. 2 lines of code, easy. And those were the local ones. So I'm going to show you a demo to this later on as a last one. But then there's one interesting way. So this is the latest one. So I haven't been shown this live to anyone before this event. So if you don't access to the local ADFS server, you can also get the configuration remotely. And the technique is called sync config. So let's see how this ADFS actually works. So you had those 2 configuration storage options. And if you are using the local database, it looks like this on the left, and your right side, how it looks when you are using SQL Server. Now, the default configuration requires that one of those servers, ADFS servers, is the primary one, which means that all the configuration changes can be only done via that server or node. So you need to log in and use or open ADFS Management Console or PowerShell, but that's the only server that you can make those changes. And then those changes are replicated to those other nodes, which are secondary nodes. And the replication is that secondary nodes is kind of connecting to the primary node and says, hey, give me a configuration. And then the configuration is moved to there and then it's stored in the local database. Now that traffic, it's SOAP over HTTP. That's correct, HTTP without the S. Okay? It's using Kerberos for authentication, but also for encryption and decryption, which means that even though that the SOAP as such, you can see the traffic, the content in that SOAP message, that's like encrypted, so you can't see that. Unless, of course, you have the password hash of that service account. Because if you have that, you can see what's inside that, and also you can emulate that process, if you will. And that's what we actually did. Now, if you are using the SQL Server stuff, there's no need for this service, right? But guess what? It's still enabled. So even though you are running the SQL stuff, there's no need for this replication service, but it's still there, which means that you can get the configuration using the same protocol, even though you are using SQL Server as a storage. So this allows you to export the configuration remotely. And this was found, as I told you, with a Douglas Bienstock on spring 2021. And it requires credentials that has permission to access that configuration. So why I said it like this so difficultly is that by default, ADFS service account can access that, and also the local admin of that ADFS server can access that, right? But if you get the credentials or the password hash of ADFS service account, you can change the configuration to include like all the domain users if you want to. So then everybody can get the configuration, regardless are they admins or not. So if I would be a bad guy, I would compromise this server, give everybody access to that configuration, and then come back like a year later when you have like re-enrolled your certificates and get a new version of that. So let's try to do that then, okay? And because we were able to compromise the Azure AD Connect server credentials, and now in my environment, I'm also using password hash synchronization, which Jorge recommended to do, and I also, that's a very, very good way. But anyways, there's one bad thing is that now that same account has rights to get password hash of any user, all users, including domain admins, and any computer or whatever accounts there are. So we can use those, which we already have here. And the first thing is that we're going to run a command that is listing an object called GMSA ADFS, which is the service account for this ADFS service. And we need to have the password hash to be able to create a Kerberos ticket. And also we need to know the object seed of that user. Okay. So now we need to get the hash. Okay. So I'm going to say get AD int user, AD user nt hash. I'm going to say server, localhost, and credentials we already had there. And then I'm going to say the object GUID, which is this one. Like this, and we want to have a hexadecimal string, and that's the password hash. We were using, again, the replication service. So the next is that we can say get AD int, export AD int ADF configuration. And we provide the server. So actually, I have 3 ADFS servers here using the same service account. So let's say ADFS 2. And I'm going to provide the hash, which was this. And then we need the user's seed, because that's how Kerberos works, right? So I'm basically crafting a Kerberos ticket here without any need. And you can do this actually offline, because I have all the material I need here. So I could do this from home if I just would have access to that. And when I do that, we should have a configuration, and there it is. So the configuration is actually an XML document that has a lot of fields, and one of those is encrypted PFX. And now that we have the key, we can decrypt those, and then we have the certificates. But how do we do that? Well, actually, it's easy now, because all the secrets was released by Douglas and Austin in this very same conference in 2019. And after that, that was actually quite easy. Again, there's a lot of small print here. You can read it later. But basically, we get the both information, and then we have the key, and we have the encrypted PFX blob. So it has some more key material, and with that DKM key and that extra key material, you derive a new key. and then with that you can decrypt the certificate. And after that you can do whatever you wanted to do with those certificates. You want to see what we can do with those certificates? Who was? No one? Okay. Just kidding. So let's move to, let's say, this ADFS number 2. Now I'm using the .NET reflection methods here, so I'm just going to export the certificates and then use them to do something. So we have now certificates. I'm just going to say export AAD int AAD certificates, and then I'm going to say, well, nothing, because I just want to use the default methods, which assumes that I'm logged in as a local admin on the ADFS server. Let's hit enter, and we should have 2 certificates here, and one is for encryption and one is for signing. Now, the nice thing with this is that when you are doing the golden SAML attack, you can choose which user you want to log in. And another feature is that it can bypass MFA by default. So even though Azure AD has like MFA requirement, you can create a SAML token that says that I already did the MFA, so don't bother. So that's why this is so like powerful attack. So let's try to do that. So yeah, well, there's a question, okay?
You say you can use MFA and trick Azure. Doesn't that depend on a setting in the federated domain that specifies supports MFA true or false? Because if it's true, then Azure AD handles MFA. Otherwise, it's delegated to ADFS. Doesn't that depend on that setting?
Yes, so there was a question that when you convert domain to federated Azure AD, there's a setting called support MFA. So does that affect this? No. So it doesn't care about that. So I don't know why the setting is there, because it doesn't do anything, but we will get back to that later because there's something we can do. But that's the next slide stuff. But now, first, I want to list users in this domain. There's not many, so these are the users. And we need that immutable ID, right? And it's the default is that it's actually the on-prem GUID, so one of these. So who do we want to log in as? Anyone? Ryan? Sorry? Isaiah? Okay. The only one I can't pronounce. Thank you for that. Okay, so where's my mouse? So I'm just going to copy the GUID here. And actually, if you have access to a Azure AD tenant as a normal user, you can actually list immutable IDs of any user. So you just need to be a user. I'm just doing here in the AD because it's easier for the demo. But basically, I'm just going to paste the GUID here, like this, and then it's going to build me the immutable ID. So it's converting that to byte array and then to base 64 encode that. So this is like how it looks like. And it's actually a string, which just happened to be like this, but if you're a global admin, you can change that to anything like cat or whatever. It doesn't matter as long as it matches what is sent in SAML token. Okay? So let's try to open a portal here. So I'm going to say open AD int Office 365 portal. I need to provide the immutable ID. And then I need to provide the certificate. That's the sign-in one. And what else piece of information we need to remember? It was the issuer. And I changed that to something easier to remember. So that usually is the kind of the name of the ADFS server, like sts.securebox.com or something like that. But it's troopers.de, okay? And I want to use, okay, browser and Edge in this computer. And actually, we also have the UPN, but that doesn't matter. Azure AD doesn't care about that. So if I don't provide the UPN, it by default is adding Santa Claus at North Pole, that's something there. But Azure AD doesn't care about that. So it can be anything. Like someone, well, it doesn't matter. And then we also have the bypass MFA. We set it to true. Hit enter. Let's see what happens. You're logged in. As easy as that. And actually, let's try that. I'm not sure is this user having this MFA enabled. No, he didn't, but anyway, well, we have actually plenty of time, so I'm going to show you some user that has MFA. So if I remember correctly, the first one does have. And let's do this again. So we are new immutable ID. Yes, yes, yes. Yeah, now it says that, okay, you need to do the MFA. Well, let's close that and try again with this set to true. Yeah, and now we are in. You want to be, yeah. Okay, so how the heck do we protect against this then? Okay. So first of all, you need to treat all ADFS servers as tier 0. And actually every component that is involved with the hybrid identity, like Azure AD Connect servers, anything that is related to that, so it has to be in tier 0. Because if you can compromise that, it's not a good thing. And there's a new setting that has been there, I think, at least since February this year, that you can configure Azure AD to reject all IDP MFA claims. So that's actually a new thing, and you can say that, okay, so actually, I don't care if you are providing the MFA claim, I don't like that. I'm still going to ask that question. And that can be configured by domain. You need to use beta Graph API to do that, but you can do that. And I don't know why Microsoft hasn't been more loud about this, but that's actually a very good setting. And then, if you are using ADFS managed certificates, you need to block the port 80 so that you can do that replication stuff remotely from all except ADFS servers and ADFS proxies. And why from ADFS servers? Because they are using that. So that's a related protocol, but your users don't need to. They don't need any other access than 443 or HTTPS to your ADFS servers. Now the proxies are a different thing because they might have been configured so that they are calling a certain endpoint. I think it's called probe endpoint, that they are trying to figure out which server is alive. And if you block that, proxy thinks that ADFS is dead and it won't work anymore. And also, if you are using the SQL as a configuration storage, you need to treat that also as tier 0. So you can't use the same server you are using like your applications. So don't do that. It has to be also in that very secure tier 0. And tier 0 means that you need to secure those as well as you secure your domain controllers. Okay? And if you are using custom certificates, you just need to block port 80 from all except ADFS proxies, because those servers don't need to talk via port 80 anymore, because they are not replicating that. So, and also use HSM, so that also helps, but you need to configure that on each server. So So that's like a hardware security model, right? Where you can store your certificates like outside your computer. So it's kind of a TPM, but it's a device that you can plug in. And if you are using those, nobody can steal your certificates. So advice from me, so if you want to be safe, use custom certificates with HSM. If you want to make it easy, don't. But it's also easy for bad guys. But with that, we still have like 10 minutes for questions, so thank you.
Thank you very much.
Nestori, regarding the custom certificates, what is your recommendation in terms of which type of certificate would you use? Self-signed certificate, like for example ADFS already uses, but then managed by ADFS, or certificate authority issued certificates, and then internal or external?
Yeah. By the way, was it recorded, or should I replay the question?
No, I think it was.
Yeah, okay. Yes. So from security point of view, it doesn't matter as long as you use it. So whatever is best for your management, so that there's no extra management like burden. So if you have like CA, use that. If you don't, you just need to pick one. So I would say that the same method that you use for other certificates. So they can be self-signed. There's no technical like blockage for that, but it's up to you, I would say.
Yeah. Well, my personal preference is to use self-signed certificates instead of the whole CA stuff, because it's not really needed. For the token signing at least, and the token encryption.
Yeah, correct.
Thank you.
Further questions?
Sorry, it's not really a question, but more a comment on the support MFA thing when you convert a federated domain. It actually does something when you do step-up MFA. So you have a token without MFA, and you need to do something that requires MFA because of a conditional access rule. It knows where to redirect you if you need to do cloud MFA or ADFS. That's what that parameter indicates. So if you set it to true, and you need to step up, it will redirect you to ADFS. If you haven't configured it, it will assume you do cloud MFA.
Yeah, okay, yeah. Yeah, that's a good point, and that works with the service provider initiated flow. But here we don't use that, so it kind of bypasses that. But that's a good point. So it has it really does something, yeah. Yeah. Any other questions? It's Dirk and I need to go.
I could probably read it in the source code when you publish it, but I was just curious how you're exporting the unexportable certificates. Are you like hooking the APIs, or is there like a secret hack around it?
Well, not that much secret, so you just need to be at least local admin. You elevate yourself to system, and then you get the certificate, and the certificate has a container name, which refers to a file name that is somewhere on your disk, and you just need to find that. There's a couple of ways to do that. And then you use the magical DP API, and that's it.
Thanks, Nestori, for the talk. About the HSM, even though it doesn't allow you to export the certificate, if you're on that same machine where the HSM is installed, can you still sign your SAML assertions by you just interacting with the HSM?
So did you ask that if I'm in the same computer that has HSM-like and you want to sign certificates? Well, technically you should be able to do that, yes, because you are on that same computer and you have access to TPM or HSM, yeah.
What is the difference is the persistence that you don't, if you lose the access to that one, then you're kind of out of the game?
Yeah.
Okay, thanks.
If there are no further questions, Nestori, thank you very much for
thank
your
you.
very interesting talk.